Nobody's seen the other thing. All right. Thank you again. I didn't understand much. I heard a few words. So I did understand you talked about infrastructure as a service, platform as a service, and that's what this session is mostly about. It's about how there's the differences and how we want to reimagine how we do compute and how people do cloud. I talk about the different products we use in cloud. We use Compute Engine. We have App Engine. Tomasz did a very good presentation on the general App Engine, so I will just talk very little bit about the new features, and then in the middle I will talk about two things we launched recently called Kubernetes and Google Container Engine. And for all these products I have very small demos at the end of it, so you can at least have an idea how they work. But basically to start, I talked about that in the beginning. We say we want to stay true to the original promise of the cloud. Things should be easy, things should be flexible, and we carry your pager really. Like you shouldn't have to care about infrastructure at all, and how the servers run, etc. And but there was something which also didn't really fit, which is infrastructure as a service and platform as a service was kind of the choice you had to make very, very early on, and then you're kind of stuck with it. So you could have chosen a platform as a service, such as App Engine, or I don't know, Heroku and whatever, and you really only care about your application, and you can run it, but you're kind of not as flexible anymore, because maybe you want to have to write your application in a special language, or you cannot easily get more powerful machines or whatever. You have like a few trade-offs you have to make when you use platform as a service, which usually is fine, but you might get to the limits. And then there's the exact opposite, infrastructure as a service. You get a plain Linux, you have to install all your servers, all your services, your libraries, you have to configure a firewall, etc. And you're very, very flexible. You can get basically to run anything, and you can have thousands of machines, so you really have to scale to back it up. But it gets a bit tedious. So we didn't like this choice, and yes, we want to allow you to be as flexible as you need, and yes, we also want to make it as easy for you as possible, and it's not the same for everyone. Like some people feel very comfortable with tuning some parameters on the Linux, others really just want to write code. So for some, these things are right, but often it's somewhere in between, and they need to be very, very well integrated. So we're planning to have kind of a mix between the two, and we're merging kind of the different compute products we have, so you can be as flexible as you need, as productive as you need to be, and you can have automatic management even if you use raw VMs, etc. So you can kind of profit from both. And in the presentation I will show how we do this in the different products. And basically, the basic products are still, you have VMs, you have what we call a cluster built of containers, and I will go into the nomenclature, what that means. And you can use platform as a service, where you manage less and less as you go to the right, but you can do more and more and be more and more flexible to the left. But it should be easy to move between the things, to combine them. Maybe you have a project which has some VMs, which has some App Engine in it, and they should be easy to communicate in between the two. Or if you decide to break out of the App Engine at some point and you need more flexibility, it should be easy as well. And how we did the first step on this and how far we are today, this is what I'm talking about. Starting with the raw infrastructure, with the VM, Google Compute Engine. We haven't talked about it yet so much. So basically, I think Tomasz gave a little intro. You can basically run anything on it. You have a pure virtual machine in the cloud. And you can build stuff on top of that, but you need to build the abstraction yourself. And if we now see what we have in features, maybe new features or different features from others, the interesting thing is you can have any size of VMs. You can have up to 16 cores. You can have any size of memory. Like we have 3 different sizes for any configuration. And you can run it as a global service. Like you choose if you want it in Asia, in the Europe, and or in the US. And in between those, you have different zones, so you can even keep a higher reliability within one region. We also have transparent maintenance now. This is something which I always like to tell with a story. We used to be our only customers, only Google software engineers writing software in the Google network and on the Google Cloud. And we like to build globally scaling services, which are N+2 redundant, etc. The way you learn it, not every startup really has the resources to do that from the beginning, but we built these. So when we had our infrastructure, the guys who did the network, who did the servers, etc., thought, oh, let's do a thing which makes it very, very easy. So we have a rotating schedule. Every week we take another part of a data center out and we do maintenance. If you have a normal local VM, there's something called ephemeral storage, where when you shut down the VM, the storage is gone. And this is very, very good for some things like Hadoop clusters, where you don't, where the system is kind of self-healing and it never all the storage goes down. But it's not very good if you run like a web server and you want to do something and you shut it down and the thing is gone. So we used to only have persistent disk storage on normal disk spindles and on SSD, which is then basically a network-based storage, and it's very, very fast already. But on the SSD side, we realized if we attach SSDs directly to the machine where the VM runs, you can have even a much higher speed, especially if you have small writes. And we go up to 680,000 read and 360,000 write operations per second with these local SSDs. You can now get with the machines. And this allows you to have like an unprecedented speed with things like Cassandra or other Hadoop products. When you shut down a machine and bring it back up, we will actually try to bring it on the same machine so you can keep your data, but we can't guarantee that. So it needs to be something which can be self-healing, which you don't absolutely need a backup from, etc. But it allows you to do disk-intensive computing very, very fast. And it also has the transparent maintenance. So when your VM moves to another zone, we move the disk with it. Like all other of our storage options, we actually encrypt all our storage. As soon as it leaves the virtual machine and goes to the physical machine, we encrypt all our storage options to make sure that nobody else, it cannot be accessed easily. So when you delete your VM or delete the disk, that key is gone and nobody ever can access your disk anymore, even ourselves. Another thing we just announced in beta is our autoscaler. It's actually coming out of an engineering team here in Europe, and they built the autoscaler for the Google internal services before. And the interesting thing is, the idea is you say, I don't want X machines. You say, I want my machines to run at this target metric. Usually it's either CPU or RAM, so you say, I want 80% CPU, or I want, let's say, 80% RAM, or I want any other metric which you can set, and it basically scales automatically. So if your machine runs at 82% CPU, it scales up a little bit slower until it goes to 80% CPU. If you go to 99% CPU, it will maybe spin up 5 more machines immediately, or 10 more machines, depending on how many you have, to make sure very, very fast the load goes down. And this has been launched in public beta, so anyone can try it out. You can also set the cooldown period, how quickly it should scale down again. And it's very, very easy to use. And there's many more ideas the team has, the engineering team. I'll do a very, very quick and basic demo on the compute engine. One thing we always talk about is how important it is to scale up and down fast. And this is something we measure very, very we measure internally a lot on how fast can you actually bring up virtual machines. So I'm going to try to bring up 100 virtual machines, and we actually wrote a little up engine script for that, so I don't have to do much. But press the start button and hope 100 machines come up. I have to give one little, if an error message comes up, this is the Wi-Fi here, it will still bring up the machines. So what happens now is this up engine up, it does API calls against the compute engine API, and it starts 100 machine, all with a Debian standard Linux on it, and boots them until they're SSHable. Yes, and now you can see the first one coming up. The blue means the machine is booting, and we have an IP address. The green means the machine is there, and this is a bit slower than normal, but now the first machines are coming up. More and more of the machines are coming up, and green means you can actually start working. Basically, what you then would usually do if you write a web application, in the moment you can reach the application, and you usually boot your own image, you have some startup script running and which runs your application. Then you add it to the load balancer and you can immediately start going. And we just about hit our metric we want to hit most of the time. We were under 1 minute with all the machines we brought up after 100. And so that's usually what you should see. Sometimes it's under 30 seconds, but really in 99% of the cases you see it ending up that you can reach all machines within 1 minute. And I'm going to shut them down because I don't want to waste any computing resources in the cloud. Yeah, so that's one metric which is very, very important for us on the computing side. Now, I want to switch gears a little bit and talk about clusters and containers. Who has heard about Linux containers, about Docker here in the audience? Okay, a few. Who has run Docker? Anyone? Okay, about the same number of people, which shows actually it's quite easy to do. So I'm going to go into details on what it is a little bit, but basically we figured out something called Linux application containers. They change a little bit the way how we do things. And it's something which is not so new to us, but it gets a bit easier with the picture. So when you run a compute engine virtual machine, this is what you all have. We manage the hypervisor. Hypervisor is like where you run in the virtual machine. We use KVM, others use something else. On that you have a virtual machine, and that, if it's a Linux machine, you have a kernel, you have the libraries, you have your code, etc. And there's a few issues with that. The first issue is if you want to bring a machine from one virtual infrastructure to the other, it doesn't always work one-to-one. Like, because the kernel has to be tied to the hypervisor, you need some kernel modules to run with the virtualization. You cannot just take a machine and bring it from Google Compute Engine to Amazon to Azure unless you have all the kernel drivers for all the three installed, etc. It just won't work. Even if you have a hard disk image, it won't work immediately. You have to do a little modifications. It's not a huge amount of work, but you can't just bring it over one-to-one. Another issue is if you ever try to install several machines, several applications on one Linux machine, you definitely came into that. They have dependencies, they run some libraries. Sometimes app number A wants library version X, app number B wants library version Y, and they're not compatible, they're not completely backwards compatible, so one of the other fails. You cannot install these two apps on the same machine. And it's the same board VMs. You cannot sometimes do that. And if you can, you're not sure if it will stay this way, because one app might get updated, needs a new library, the other app might stay on the old one. You cannot be sure that it always works the same way. So what could you do? You could run several VMs, one VM for every app. But there's kind of this thing, some things are always the same. The kernel and the base Linux installation, it's all the same. And you suddenly have that overhead of the kernel, which you don't want to have. So that's the idea where containers come in. we create another abstraction layer, and it's basically you keep the kernel and the base Linux always the same, and you just change what libraries you have and what kind of code you have. And this is nothing which basically is very, very new. People have been trying to do that for quite a few years. And how you then run applications is basically you run on one virtual machine, you run a few containers which all contain their own libraries. They don't interact with each other. The apps can only talk each other over like network. It's not real network, it's the virtual network, but they cannot basically disturb each other. So this is much better. And it's nothing new, like this isolated environments, we've done it over many years called LXC, Linux containers, and there have been other ways of doing it. Recently it's been popularized by something called Docker, and Docker built a great community. Lots of startups started building on Docker, and Docker actually said, wait, we're actually still in beta. Docker came out of beta in June, and people quickly picked it up and starting to run stuff with Docker in production. And what does Docker do? Docker makes it easy to build these containers and to manage them. Like you can have a registry of containers, you can quickly say how you want to deploy them, etc. We've been doing this for years, not with Docker obviously, and everything in Google runs in a container, up to a point that because we actually built applications very, very modular, and that's the new idea, that you build applications modular as kind of microservices where everything only does one thing. And we've been doing this for a while as well, up to a point that we start over 2 billion containers a week in Google. So this is nothing new to us. The Docker thing is new to us. And actually, since we've been doing this like about 10 years, we've done it a little bit different. What we did is we just packaged the binary of the application and all the libraries together and sign it with it cryptographically to make sure its integrity is good, and we put that all in one big package, in one big binary package, which we have the container, and then we built some isolation on top of that, etc. Docker makes it a bit easier because ours works quite well in our environment where we write all the code, etc. But if you want to use open source software, it's sometimes a bit hard to get it running. So Docker is much easier. They use something most Unix sysadmins have heard of, something called change root, where you just basically change your root directory, so you have a whole new environment which looks like it's your whole machine, but it's not. And that's how they basically, with every Docker container, it looks like a full Linux. It fakes some things like the hardware, proc calls, etc., all of that. But you can basically install any kind of open source software in a Docker container. And you can even use your normal tools you know from Linux, like apt-get, aptitude, whatever, to install packages. So it's much easier to use. And if we started from scratch, we would probably do this way. Our way, we still continue doing it because we do it everywhere, but we like the Docker structure much better. That's why our open source system, Kubernetes, which I will talk about, runs on Docker as an underlying container infrastructure. Now, why is Docker not everything you need? It's kind of missing a little bit something. Docker is great for packaging up containers, for bringing them up somewhere very, very quickly. To build services, you need a little bit more. If you want to build scalable web service, you need not only your Linux and some container manager, which Docker can provide, but you also need to schedule them. You have a bunch of machines. With Docker, you need to say, okay, now I want to have application 1 on server A, application 2 on server B, application 3, I think there's still a bit space on server A, and all of that. And this is great while you run small applications, but if you run larger applications and scale up and down and do all this automatically, you want to really some kind of scheduler, which is basically what Kubernetes is. And we released Kubernetes as an open source project. into the community based on Docker, because there was no cluster scheduler based on Docker. Well, none which got a lot of traction. So we said, we wrote our own for our own kind of containers. We can do this again. And we released it while it was in the very, very early stage. So it's still in beta. But basically, it should do all of that. You can replicate your services, resize your services, name your services, and schedule the containers across a bunch of machines you have. Very, very quickly after we released it, we had a bunch of other companies join ship for different reasons. Like our Kubernetes is very modular. You can run it on any kind of cloud. Our example is the Google Compute Engine. So we show you how to run it on Google Compute Engine, something else, write a plugin. So Microsoft wrote a plugin for Azure. VMware wrote a plugin so you can run it with VMware, etc. But we also had Red Hat, which basically they are developing their own basically cluster infrastructure, and they want to build on Kubernetes as a scheduler for that. So they are a very major contributor to the whole system. And CoreOS is a Linux distribution which wants to become the standard for running containers, because they want to build a container optimized system. So they joined so they can make sure. Mesosphere is another scheduling service, not for containers, but for any kind of jobs, and they want to make sure Kubernetes works very, very well with Mesosphere. And so we had IBM, soft layer integration and all of that, so we had a lot of traction. And it's an open source project on GitHub. It's on kubernetes.io, and we had lots of people contribute already. It's still in version 0.52 or something was this week. So we're a bit from 1.0, but you can see what we're planning to have by the end. And just want to very, very quickly go over the basic architecture. So basically, one thing is we realized containers sometimes live together, like a web server and its content management system usually are together. So we call that a pod. And so what I call here is like a front end. It could be a pod where everything what I need for a front end, they should be together, and they should be on one physical server or on one VM together. And then we have something called services, where we say, how do you actually address things from the outside? And then we have things called labels, where you say, oh, I want to give version 1, version 2, production, and I want to run these in parallel. And this is kind of the basic idea for Kubernetes. You have services, you have labels, and you have pods, and you have replication controllers, where you say, how many of those do I want to run? So for the front end, you can say, I want to run 4 front ends, 2 back ends, and here are my machines. Now run them. And Kubernetes takes care of the rest. Oops. And the thing is, you don't have to bring even this whole Kubernetes stack up yourself. We just announced in Alpha something we call Google Container Engine, which makes it very, very easy to start with the containers with the same tools you use on Google Cloud Platform. Still in very early stage, I need to say that. It's public alpha, so you can try it out today. But don't expect never anything to fail. And please don't use it in production quite yet. We're moving fast. We announced it 3 weeks ago, but yes, it's still in alpha. And basically what Container Engine does, it merges Compute Engine with Kubernetes. It gives you a pre-installed Kubernetes cluster on Compute Engine where you can schedule things using our Google Cloud SDK. And I want to very, very quickly demo that as well. So in our developers console, where you can manage all the products between Compute Engine, App Engine, your source code for App Engine, etc. And there's also now Container Engine there. And this is with just a little click of a button. You can also use the command line, of course. You can bring up a new cluster, call it Reductusoft. And you can say where it should live. This one should live in Europe. I want 4 VMs or 5, let's say 5 VMs in it. And they should be, let's say, 4 cores each. and it tells me now exactly what I will have available. I will have 20 CPUs, 130 gig of RAM available, and I can schedule containers in that. And basically, once I click create, it starts creating that cluster. Now this takes about 2 or 3 minutes, so I will continue on with the cluster I already created before. And hopefully, let me see, I have an SSH window still open. Oh, disconnected, hold on. Okay. So basically, well, I use a Chromebook, so I use this to claim I have a Linux machine, but in the end, this runs in the cloud as well. So to bring up a service on this cluster I now created, I can use the normal command line tool for, can you read this? Yes. Compute engine, which is called gcloud. Because it's still an alpha, I add preview, and I say I want to run on the container engine. And I can first do something called clusters list to see what clusters I have. Okay, I see I have the 2 clusters. I don't know if the new one already is up completely, so I will work with the one I know. And now I want to bring up a new service. And now I want to create a new pod, and I can say I want to run it in the cluster name. This is the name of my cluster. And now I need to say what do I want to call it. Now let's say I want to install WordPress. And very simple example, I can say, okay, Docker actually has an image for WordPress already in their public registry, so I can just use that. It's called Tutum WordPress. So I read about this and I find, okay, this might cover my needs. So that I want to call that pod WordPress, and I want to use the image I just learned about, Tutum WordPress. Okay, oh, I miss one. I need to say on which port I want to make this service public. I use port 80. And this is basically all I need to do to deploy the service. Now, instead of pods create, I do pods list. By now, it should hopefully have deployed. It only takes a few seconds. And it's running on this IP address. If I go back and now go on this IP address, I have a fresh WordPress installation which I can keep running on. So that's how easy it is to run basically a ready-made service, and you can build it together. You can have Redis and whatever. It doesn't need to be a web service, etc. And now I want to actually delete this one again. And now I quickly want to show you the self-healing component of how Kubernetes works. So for this, I use a service which is a custom image, which basically it runs a little web server and runs an image just for demonstration purposes. So, and I built a little visualization on top of this. So, first I want to start that service and start a replication of 2 of these. Oh, there it is already. 2 of these web servers which show a specific image. And okay, 2 is good. Let's see how I can do this. Maybe I make this smaller so we can see it at the same time. Now I want to try to scale this up, and what I give Kubernetes a little command which says I want to now change, and I want to have 4 replicas of this service. And I run it, and well, you see how fast it scales because it just brings up new containers. Containers run in seconds. Now, what we do a lot within Google is something we call rolling updates. So if you have a new version, you don't deploy it globally right away, but we deploy it slowly with slowly. So over a few hours, you deploy it over the cluster, so users can be smoothly migrated from one version to the next. And you get feedback if something goes wrong, hopefully while the thing is still rolling out. Now for this demo, I don't want to wait quite a few hours, so I sped up the system a little bit, so I want to now deploy the new version every 10 seconds to a new cluster. And you can see the new version shows a much improved image of a cat. So now it's deployed on half the cluster, and you can see every time I bring down a service and I bring up a new service, well, we just go down by one replica, which you should not ever run the load to full replicas, and you bring up the new version, and that way the service can run smoothly over the load balancer, etc. And now all the 4 things have started, all the 4 containers. Now, actually I want to show not only can you do this in a planned way, but you can also do it in an unplanned way. So I'm kind of, will simulate a catastrophe, so I will actually pretend one of these nodes goes down. So I go to, actually I log in directly to the machine which runs one of these cat containers. Node 2, let's say, is the first one. Okay, now I'm on that node, and actually I can run Docker to see all the containers running on this machine. Oops, now I need to make this a bit bigger so you can actually read it. And there's the first one you can say is the kitten. So I can actually just, with Docker, kill that container. I don't want to say what else I'm killing with the container. And as you can see, one of those actually stops serving the image right away. But in that moment, the health check is failing, and it starts immediately trying to self-heal the system, and within a few seconds, a new container has been spun up, which lets us reach the desired number of replicas again. So that's basically showing the self-healing of Kubernetes. There's many things not yet implemented in Kubernetes. For example, load balancer is still a software load balancer. It doesn't yet integrate with like the Google Compute Engine load balancer, but that's why we're not 1.0 yet. So that's the little demo of Container Engine. And now for the very quick end, I just want to have a few words about App Engine. Tamas did a very good presentation about App Engine, how basically it helps you to abstract all the stuff like the app environment, which includes the web server, the app server, the interpreter, from you as the developer. If you use platform as a service, you only care about your code and libraries. Actually, there's more than that. The autoscaler is included, the load balancer is included. You don't even care about how many servers you run, and you can do all that between a highly modular app. You can run many modules in parallel. I think you talked about modules. Yes. Good. And not only that, but it's even globally replicated between different zones. So even if one of our data centers completely goes down, your application still runs. And you get all of that with App Engine. You care about app code and libraries, and we care about everything else. But this came with some little bit decisions you had to make. You had to use one of the languages we support, like PHP, Python, Go, or Java, and you had some restrictions in terms of what libraries you can use. And this we try to address with something we call managed VMs. And so what managed VMs do is they run App Engine, not anymore within our completely managed infrastructure, but within VMs, which are also managed by us though. So you don't care about these VMs. You do see the VMs in your console. You can log into the VMs if you want to, but you don't need to. We bring up VMs, we bring down VMs. So you have to compute the full automatic management of App Engine. But you have a flexibility of Compute Engine. Like on these VMs, you have a complete secure system. So we allow you to install any libraries you want. So suddenly you don't have any restriction on Java library anymore. You can access all the native resources. You can have all the machine types we offer on Compute Engine. With App Engine, we give you a few types, but it goes with Compute Engine, you can go up to 16 cores. So if you have very compute intensive mechanism, you can do that now on App Engine as well. We do the image updates, we do the security patches, we add the machines to the VMs to the load balancer, etc. We do the health checking, so we make sure everything runs. And that way, basically, we can also allow you to co-locate with other services. So if you have already Compute Engine running, you can be in exactly the same zone, and you can have very, very fast network infrastructure between the two. So that's kind of like where we merge the two products. You can have all the knowledge how to do things with App Engine, but it runs on a managed machine. And we just launched it open for all, and there's a few new features. The load balancing wasn't completely included, now it's completely included. Now you have full auto-scaling support, it's completely integrated in our SDK. And there's something where we come back now to the container space. If you say, I don't want to even write in one of the 4 languages you support, you can bring your own language. You just need to write a Docker container, which includes the runtime for this. And we will just deploy that Docker container. And you can have App Engine basically in any language. We published an example for Node.js, but internally we tested a ton of languages, even like, I don't know, Fortran. We had App Engine, someone write an App Engine up in Fortran, and yeah, it was quite interesting. So you can do that now with this Docker integration. And how do you do that? Basically, so first you specify your resources. You do that already, and you just add a Docker file, and you use the same kind of up deploy, and the whole thing runs. You don't need to bring up any VMs or use any other products. You only use the App Engine SDK. For managed VMs, I have a very, very quick demo. Unfortunately, with App Engine, you never see what's behind, so I'm going to explain that a little bit. So the example is about Sudoku. And solving Sudokus programmatically is actually quite easy. It's an easy mathematic function. It's easy to do for a computer. Now, if I get a newspaper from here, like this Metro thing, then there's a Sudoku inside, but I don't want to now put in every number and do that. So the idea is to solve even those kind of Sudokus automatically. But for this, we need something we call computer vision, and a library we call OpenCV can do that in an open source way. That can try to detect some kind of grid and detect the numbers and do the OCR and stuff. But the issue is it's written in C++. It has interfaces. It needs libraries which were not supported by App Engine. So that's where managed VMs comes in. So what we did is we built an App Engine front end, and we built the backend workers on VMs, which get whenever I have a Sudoku which I want to solve. And basically, so I have 2 modules. The front end is just the same, which Tamas would be using, and the backend, the kind of these App Engine YAML files you use for everything but Java. The only thing you add to run it on a VM is that line you see there, VM equals true, or VM : true. And then you say what module you want to run, and the whole thing starts on a VM. And you can say, what machine type do you want? We just use a 1-core VM in this case. And you can say, what libraries do I need to install? And that just installs the libraries using the normal Linux file system. And then, once you have written that, you use the same gcloud command to update your app, and that's it. And it comes online. Let's hope it works. Unfortunately, here the weak point is the camera of my laptop. So I have this Sudoku, which I bought today. I'll give it 1 or 2 tries, otherwise I'll cheat a little bit. So I'm going to try to scan it. Need to hold it very, very straight. Probably not light enough. Let's try this. I see it's no. Needs to focus a bit better. Like this. I'll try one more time. No, this is this won't work, I can tell you. I don't have a very... No, what I will do is I will cheat a little bit and I will upload what I scanned before with the same camera, but it's the same Sudoku, I promise you, and I had a much better hand in this moment. So I will click solve on this one, and in the backend it ran on the VM and run the OpenCV to get the grid and solve the Sudoku. So that's what you can now do with managed VMs. With App Engine before, it would have been really, really hard to do that. And that's it from my presentation. Thank you. And now I want as many questions as Tamas had. Yes. We're thinking about it to do it a huge program. We have a program now with which we call the Google Startup Pack, which is very, very attractive because it's $100,000 for a whole year. But it's only for people who have a startup which are in a partnering incubator, accelerator, or with a partnering VC. So if your VC incubator accelerator is not partnering yet, you could contact me and I could try to make that happen. And yeah, then you can have this, well, I would say all you can eat. There are the first ones who spend more than 100,000 in a year, but for most startups, this is like all they need in a year to do a lot of playing. So if you have a startup and if you are part of some VC incubator accelerator, then come see me and I will see what we can do. If not, we'll try to do something else. Okay, any other questions? Come on. So you're all ready to publish your Docker containers? Yes. Okay, so the issue between not allowing the different packages was actually because internally we ran it on our own container infrastructure. So every time you deployed App Engine, we would bring up containers. And what you need to know is that a container is not a complete security parameter. So you can theoretically come from one container to the other. So we only allow libraries where we know this cannot happen. That's why we run Docker and Container Engine inside a virtual machine, because the virtual machine is safe and you can never get out of your virtual machine. So that was the reason behind it. The reason why we didn't do it inside a VM from the beginning is A, Compute Engine is newer than App Engine, and B, although you can start like in 50 seconds or something a VM, App Engine, the traditional way, you can actually start new containers in 2-3 seconds. So it depends a bit on how fast you need to scale. So maybe if you have a front end which is very, very changing, you should still run it on the traditional App Engine, but for everything else, we think managed VMs is a great way. Cool. Any other questions? Okay. Then thank you for your time, and I'm still around.